Hello guys, me back again. My name is N. Today we are gonna talk about Nikola Tesla. If you are thinking where is the basics of electricity part 2, then I wanna say I am gonna make after this video. So, let's see what we have got. Let's see. Nikola Tesla was a Serbian-American inventor, electrical engineer, and futurist, best known for his contributions to the design of the modern alternating current AC electricity supply system. Born and raised in the Austrian Empire, Tesla studied engineering and physics in the 187OS without receiving a degree, gaining practical experience in the early 1880s working in telephony and at Continental Edison in the new electric power industry. Here are some of the key contributions and achievements of Nikola Tesla. Alternating current AC. Tesla's most significant contribution was the development and promotion of the AC electrical system. He designed the first practical AC motor and transformer, which allowed for the efficient long-distance transmission of electricity. This system eventually became the standard for electrical power distribution worldwide. To these days we can say, everywhere we AC current to power our equipments, but devices like our phone or computers are used DC current to work. We convert the AC into DC by bridge rectifier, then we use that DC current to power our devices. Tesla coil. Tesla is also famous for inventing the Tesla coil, a resonant transformer circuit that produces high voltage, low current, high frequency alternating current electricity. Tesla coils have been used in various applications, including wireless transmission of electricity and as a component in early radio technology. It works by resonance. Wireless power transmission. Tesla was a pioneer in the concept of wireless power transmission. He conducted experiments with wireless energy transfer and had a vision of providing electricity to remote locations without the need for wires. Although his wireless power transmission ideas were not fully realized during his lifetime, they have inspired modern research in wireless technology. This circuit used Tesla coil or other devices to transfer power wirelessly. Tesla was so convinced that this will work, but that time didn't work that much sufficiently. But it can work in future. Radio. Tesla made significant contributions to the development of radio technology, and he is often associated with the invention of the radio. However, his patents were contested by other inventors, most notably Guglielmo Marconi, and there was a legal battle over the invention of radio. Remote control boat. Tesla developed boat, which is one of the earliest remote control devices, which he demonstrated by using radio waves to control a small boat. This technology laid the foundation for the development of remote control systems in various applications. X-ray imaging. Tesla also experimented with X-ray technology and produced early X-ray images, though he did not patent his work. His X-ray experiments predated the official discovery of X-rays by Wilhelm Conrad Röntgen. Induction motor. Tesla's development of the induction motor was a critical invention for industrial applications. It is widely used in various machinery and appliances. Today's days we use many types of induction motor like single-phase induction motor and three-phase induction motor. Tesla attempting to develop inventions he could patent and market. Tesla conducted a range of experiments with mechanical oscillators, generators, electrical discharge tubes, and early X-ray imaging. He also built a wirelessly controlled boat, one of the first ever exhibited. Tesla became well known as an inventor and demonstrated his achievements to celebrities and wealthy patrons at his lab, and was noted for his showmanship at public lectures. Throughout the 1890s, Tesla pursued his ideas for wireless lighting and worldwide wireless electric power distribution in his high-voltage, high-frequency power experiments in New York and Colorado Springs. In 1893, he made pronouncements on the possibility of wireless communication with his devices. Tesla tried to put these ideas to practical use in his unfinished Wardenclyffe Tower project, an intercontinental wireless communication and power transmitter, but ran out of funding before he could complete it. After Wardenclyffe Tower, Tesla experimented with a series of inventions in the 1910s and 1920s, with varying degrees of success. Having spent most of his money, Tesla lived in a series of New York hotels, leaving behind unpaid bills. He died in New York City in January 1943. Tesla's work fell into relative obscurity following his death, until 1960, when the General Conference on Weights and Measures named the International System of Units SI measurement of magnetic flux density the Tesla in his honor. There has been a resurgence in popular interest in Tesla since the 1990s. Nikola Tesla was born an ethnic Serb in the village of Smiljan, within the military frontier in the Austrian Empire, present-day Croatia, on the 10th of July or the 28th of June 1856. His father, Milutin Tesla (1819–1879), was a priest of the Eastern Orthodox Church. Tesla's mother, Yuka Mandik (1822–1892), whose father was also an Eastern Orthodox Church priest, had a talent for making home craft tools and mechanical appliances and the ability to memorize Serbian epic poems. Tesla learned many things from his mother he have mentioned. Yuka had never received a formal education. Tesla credited his eidetic memory and creative abilities to his mother's genetics and influence. Tesla's ancestors were from western Serbia, near Montenegro. Tesla's rebuilt house parish hall in Smiljan, now in Croatia, region of Lika, where he was born, during the Yugoslav wars. Several of the buildings were severely damaged by fire. They were restored and reopened in 2006. Tesla was the fourth of 5 children. He had 3 sisters, Milka, Angelina, and Marika, and an older brother named Dane, who was killed in a horse-riding accident when Tesla was age 5. In 1861, Tesla attended primary school in Smiljan where he studied German, arithmetic, and religion. In 1862, the Tesla family moved to the nearby Gospic, where Tesla's father worked as parish priest. Nikola completed primary school, followed by middle school. In 1870, Tesla moved to Karlovac. Better source needed to attend high school at the Higher Real Gymnasium, where the classes were held in German, as it was usual throughout schools within the Austro-Hungarian military frontier. Tesla later wrote that he became interested in demonstrations of electricity by his physics professor. Tesla noted that these demonstrations of this mysterious phenomena made him want to know more of this wonderful force. Tesla was able to perform integral calculus in his head, which prompted his teachers to believe that he was cheating. He finished a 4-year term in 3 years, graduating in 1873. After graduating, Tesla returned to Smiljan but soon contracted cholera, was bedridden for 9 months, and was near death multiple times. In a moment of despair, Tesla's father, who had originally wanted him to enter the priesthood but then promised to send him to the best engineering school if he recovered from the illness, Tesla's family did not hear from him after he left school. There was a rumor amongst his classmates that he had drowned in the nearby river Mur, but in January one of them ran into Tesla in the town of Maribor and reported that encounter to Tesla's family. It turned out Tesla had been working there as a draftsman for 60 florins per month. In March 1879, Milutin finally located his son and tried to convince him to return home and take up his education. In Prague, Tesla returned to Gospic later that month. When he was deported for not having a residence permit, Tesla's father died the next month, on the 17th of April 1879, at the age of 60 after an unspecified illness. During the rest of the year, Tesla taught a large class of students in his old school in Gospiken, January 1880. 2 of Tesla's uncles put together enough money to help him leave Gospic for Prague, where he was to study. He arrived too late to enroll at Charles Ferdinand University. He had never studied Greek, a required subject, and he was illiterate in Czech, another required subject. Tesla did, however, attend lectures in philosophy at the university as an auditor, but he did not receive grades for the courses. Working at Budapest Telephone Exchange, Tesla moved to Budapest, Hungary, in 1881 to work under Tivadar Puskas at a telegraph company, the Budapest Telephone Exchange. Upon arrival, Tesla realized that the company, then under construction, was not functional. So he worked as a draftsman in the Central Telegraph Office instead. Within a few months, the Budapest Telephone Exchange became functional, and Tesla was allocated the chief electrician position. During his employment, Tesla made many improvements to the central station equipment and claimed to have perfected a telephone repeater or amplifier, which was never patented nor publicly described. Working at Edison, in 1882, Tivadar Puskas got Tesla another job in Paris with the Continental Edison Company. Tesla began working in what was then a brand new industry, installing indoor incandescent lighting citywide. In large-scale electric power utility. The company had several subdivisions and Tesla worked at the Société Électrique Edison, the division in the Évry-sur-Seine suburb of Paris in charge of installing the lighting system. There he gained a great deal of practical experience. In electrical engineering, management took notice of his advanced knowledge in engineering and physics and soon had him designing and building improved versions of generating dynamos and motors. They also sent him on to troubleshoot engineering problems at other Edison utilities being built around France and in Germany. Moving to the United States, in 1884, Edison manager Charles Batchelor, who had been overseeing the Paris installation, was brought back to the United States to manage the Edison Machine Works, a manufacturing division situated in New York City, and asked that Tesla be brought to the United States as well. In June 1884, Tesla emigrated and began working almost immediately at the Machine Works on Manhattan's Lower East Side, an overcrowded shop with a workforce of several hundred machinists, laborers, managing staff, and 20 field engineers struggling with the task of building the large electric utility. In that city, as in Paris, Tesla was working on troubleshooting installations and improving generators. Historian W. Bernard Carlson notes Tesla may have met company founder Thomas Edison only a couple of times. One of those times was noted in Tesla's autobiography where, after staying up all night repairing the damaged dynamos on the ocean liner SS Oregon, he ran into Batchelor and Edison, who made a quip about their Parisian being out all night. After Tesla told them he had been up all night fixing the Oregon, Edison commented to Batchelor that this is a damned good man. One of the projects given to Tesla was to develop an arc lamp-based street lighting system. Arc lighting was the most popular type of street lighting, but it required high voltages and was incompatible with the Edison low-voltage incandescent system, causing the company to lose contracts in some cities. Tesla's designs were never put into production, possibly because of technical improvements in incandescent street lighting, or because of an installation deal that Edison made with an arc lighting company. Tesla had been working at the Machine Works for a total of 6 months when he quit. What event precipitated his leaving is unclear. It may have been over a bonus he did not receive, either for redesigning generators or for the arc lighting system that was shelved. Tesla had previous run-ins with the Edison company over unpaid bonuses he believed he had earned. In his autobiography, Tesla stated the manager of the Edison Machine Works offered a $50,000 bonus to design 24 different types of standard machines, but it turned out to be a practical joke. Later versions of this story have Thomas Edison himself offering and then reneging on the deal, quipping Tesla, "You don't understand our American humor." The size of the bonus in either story has been noted as odd, since Machine Works manager Batchelor was stingy with pay, and the company did not have that amount of cash equal to $1,628,519 today on hand. Tesla's diary contains just one comment on what happened at the end of his employment, a note he scrawled across the 2 pages covering the 7th of December 1884 to the 4th of January 1885, saying goodbye to the Edison Machine Works, Tesla Electric Light and Manufacturing. Soon after leaving the Edison Company, Tesla was working on patenting an arc lighting system, possibly the same one he had developed at Edison. In March 1885, he met with patent attorney Lemuel W. Searle, the same attorney used by Edison, to obtain help with submitting the patents. Searle introduced Tesla to 2 businessmen, Robert Lane and Benjamin Vail, who agreed to finance an arc lighting manufacturing and utility company in Tesla's name, the Tesla Electric Light and Manufacturing Company. Tesla worked for the rest of the year obtaining the patents that included an improved DC generator, the first patents issued to Tesla in the U.S., and building and installing the system in Rahway, New Jersey. Tesla's new system gained notice in the technical press, which commented on its advanced features. The investors showed interest in Tesla's ideas for new types of alternating current motors and electrical transmission equipment. After the utility was up and running in 1886, they decided that the manufacturing side of the business was too competitive and opted to simply run an electric utility. They formed a new utility company, abandoning Tesla's company and leaving the inventor penniless. Tesla even lost control of the patents he had generated, since he had assigned them to the company in exchange for stock. He had to work at various electrical repair jobs and as a ditch digger for $2 per day. Later in life, Tesla recounted that part of 1886 as a time of hardship, writing, "My high education in various branches of science, mechanics and literature seemed to me like a mockery.